All right, so today's warm-up, make sure, let's see, I am going to remind you how to get into it. So I am already logged into a student's, you can't see that. I am already logged into a student's account. So to get into your warm-ups, go to Canvas. Canvas is in discussions. So I'm going to go to the Mrs. Metz homepage. Click on discussions. Today is October 15th, right? This one on here is not at the top, which is fine. It's not the end of the world. Today is October 15th, 2020, so I'm going to click on it. Number 1 says, shade the thermometer below to represent a liquid turning into a solid. And if you notice the note below, it says, since you cannot shade number 1, just tell me where you would put the shade to. How far up are you going to shade? What degree in Celsius does a liquid turn into a solid? Number 2, students place a beaker of water on a triple beam balance. Explain the steps the students should take to find the mass of the water only. Of the water only. So, that's going to take a little bit of thinking. So think about that. I'm going to go ahead and give you 5 minutes. No. It is 0 degrees Celsius, but what is it in Fahrenheit? Come on in.
0 degrees Fahrenheit to 0 to 25 degrees Celsius.
Not quite. 0 degrees Celsius is the freezing point. What is it in Fahrenheit? Tyler. All right, Sujab.
0 Celsius to 30.
Not quite. Not quite. It is 0 degrees Celsius and 32 degrees Fahrenheit are freezing points. 0 degrees Celsius and 32 degrees Fahrenheit are freezing points. Sujab.
I learned this for the first time. I was trying to remember. I think it was 35, but
you were awfully close. You were so stinking close. Scarlett.
Is it 32 Fahrenheit?
Yes, I just said that. Did you not hear it? That's funny. I find that to be quite humorous. All right, guys. You have 1 minute to, well, let me show you. Let me walk you through this. So I am going to use this student's. I'm going to go back to the home page. Scroll down to week 9. Today is week 9, day 4. Right there, week 9, day 4. Thursday. Click on it. Your objective today is you will be able to differentiate among the forms of energy, including mechanical, sound, electrical, light, and thermal. your instructions. Click on the link below to go back to the original assignment in Google Slides because we are going to continue with our forms of energy review. Or you can go back to yesterday's and open up your CAMI file. All right? I am going to give you 1 minute to do that. You have 1 minute. Talia.
How do you get to Google Slides?
I just explained that. So if you missed it, you're going to have to go back and watch the video when I post it. I just seriously just demonstrated underneath the, like, I can see it on the screen. I'm not trying to be mean, but I have made it very clear that you need to be listening the first time because I do not repeat things. Do not repeat things. I mean, I just did, and I do. I repeat, like, sentences. Quick sentences, but not instructions. You need to be paying attention at all times because if there's something that you miss, you're going to have to go and watch the video after I post it. You got to be all in, guys. All in. Got to be all in. Our goal even says we are intentional and purposeful. That means you're all in. We're all in. Our mission statement says we are here to gain knowledge, to work, and to learn. We will not accept anything less than our best. Well, if you're not listening, you're accepting less. Got to go all in. Let's go all in. You're all in, my friends. All in. All right. So raise your hand if you can tell me where we ended yesterday. Where did we end yesterday? Scarlett.
Ended on the salmon t-shirt. Describe the characteristics of a salmon t-shirt.
Okay, so did we finish this? Yes, again, I'm getting a lot of nods. All right, so the next piece we need to do is, so we did this, nope, we did this. I read this. And we need to watch this. Yes? So now we need to watch the video on sound. Did we watch the video on sound? No? All right. We are going to watch the video on sound, but I have to do this. All right. So now let's talk about filling this out. So raise your hand if you can tell me what is sound. Y'all can't see my screen. See? I can control that, right? Did you catch that? I can control that. So hang on, let me switch that. I'm waiting for everything to catch up. All right, Tyler, can you tell us what sound energy is? What is sound energy? What am I going to put in this little circle right here?
Sound energy is vibration.
It is vibration. I love it. Now we're going to start listing some facts about sound energy. And here's the thing about listing facts about sound energy. I am not going to confine myself to this little box. I'm going to write all around that little box. I'm not talking about examples of sound yet. I'm talking about facts. Just the facts. We'll get to the examples in just a second. So raise your hand if you can tell me a fact about sound. Come on.
Sound energy
travels in waves. Scarlett.
Sound energy goes back and forth really fast.
Oh. Chloe.
It creates a vibration when you hear sound.
Cruz.
It can't disappear.
Sujav.
When someone makes a sound, the sound first goes to our eardrums and then goes to our brain.
Yes. Oh, wrong way. Who else has got something? Y'all are writing all these down, right? You're typing them in or you're writing them all down in your notes? Yes? Yeah? Yes? Yes, I know you are. I know you are. Oh, I know you are because y'all are that good. Y'all are here to learn and you follow instructions. Come on.
Sound energy can be an echo.
Oh, yeah. What else do we got? Anything else? Going once. Going twice. Done. Let's move on to examples of sound. What are some examples of sound? Examples of sound. Tyler.
An example of sound is like that can and that rubber band.
Okay. She called that a what?
A guitar.
Yeah, a musical instrument. Anli. Scarlett.
Example of sound is a TV.
Yep. Kamani. Did you have one? Yep.
Sound energy can be any type of energy.
Oh, well, we're talking about examples of sound. Jeremiah.
A speaker.
Speaker. Natalie.
A computer.
Yeah, my computer's creating sound right now. Come on.
Our voices.
Voices. Yes, ma'am. Jeremiah, you got another one?
Awesome.
Yeah. My phone makes all kinds of noises. Layla.
A laptop.
Yeah. Tyler.
Dropping an object.
What?
Dropping an object.
Dropping objects. What else? Cruz.
A car.
Yep. So, could we do this all day long? Possibly.
An iPad.
An iPad. So just about everything makes noise, right? All right. So I think we kind of get the idea with sound. So we're going to move on to heat, okay? We're going to move on to heat. So let me go back to the slideshow. And I am going to read this slide, and then we will fill out the little spider web map thing. All right, heat energy. Heat energy is the energy of moving particles. Another word for heat energy is thermal energy. Particles move faster the hotter something is. Temperature and heat are not the same thing. Temperature is the measure of how hot or cold something is. Adding or taking away heat can change the state of matter of an object. For example, heating a chocolate bar makes it melt into a liquid. The sun, a fire, a stove burner, and an oven are all examples of things that give off heat energy. Heat can also be transferred to different objects in many ways. Without heat, our lives would look and feel very different. So let's take a look at this page. So go look at this either on your Google Slides or in your Cami. In your Google Slides or in your Cami, and let's see if we can't fill this out. Raise your hand if you can give me one fact about heat energy. Jeremiah. It could cool us off if we're cold? Yes, it warms us up. Come on, E. Combined with light. Did y'all get all this from what I just read? Chloe.
It won't let me type in the Google slide.
All right, Scarlett.
Heat and temperature are different?
Yep. Talia.
Heat energy can be produced by some things.
Produced by other objects?
Yeah.
Kaden.
Heat energy. When does it take of heat energy? A flame can heat up to over 1,000 degrees Fahrenheit.
I had no idea. You're right. Flame, but I don't want to do examples yet. I'm not ready for examples yet. We'll get to the examples and we'll add that when we get to the examples. Tyler. What did I say? Go ahead. Sorry, Tyler.
The energy can be taken away by either air or water.
Did you get that from what I read?
No.
I'm not going to write that down because I didn't read that. I feel like we're just kind of throwing out things that we think are true, but not proven. I mean, is it really taking away heat or is it cooling something down? And are those the same thing or are they different? Scientific questions to ask, but we got to be very careful with what we're putting down on here. So, heat energy is also thermal. Heat energy is created by moving particles. And I'm also going to add here that hotter or faster equals hotter. Okay? Faster equals hotter. It can change the state of matter. It transfers to different objects. Which is called conducting. That is conducting heat. Y'all can't see that. There you go. That is called conducting heat. When it transfers to a different object, that is called conducting heat. So I'm going to give you 2 minutes to write down what you can. If you get it, great. If you don't, that's fine. And then we will move on to the video on heat. You have 2 minutes and go. Nope, that's 2 hours. Go. Energy is very useful to all living beings. Plants use light and heat energy of the sun to grow and make food. Animals eat these plants. Other sources of heat energy are heater, gas stove, fire, and hot water bath. We use heat energy for cooking food, to warm ourselves in winters, and to make electricity. So, let me reshare, and so we can fill out this piece. All right. Kamani, you want to tell me what heat energy is?
Heat energy is the first energy that is useful for cooking and...
I don't know that that's a definition. I think that's the fact. I think that is a fact, not a definition. But possibly. It's a result of moving particles. Is that what you said? Okay. So heat energy is a result of moving particles. Not particles. Particles. Heat energy is a result of moving particles. It's a result of moving particles. That is the definition of heat energy. So basically, the faster these little particles move makes it hotter because it creates friction. It's kind of like the friction if you rub your hands together. What happens to your hands? That friction is what creates the heat. All right, Kamani, come back and tell me what you said so we can add it to the facts.
Heat energy is a source of energy that is useful and helpful for cooking and keeping us warm.
Source that is useful and helpful. You are absolutely correct. You are absolutely correct. Tyler.
The energy can be transferred to one object to another.
I am just all kinds of missing letters. Scarlett.
Heat energy can turn into electrical energy.
Can it?
That's what it said in the video.
Did it?
There's a way to do that, though.
I think you may be right.
It can combine with electrical energy.
I mean, all right. It's called thermal electric heat. In case y'all are wondering. So what did you say, Scarlett? Can create electricity?
It can become electrical energy.
Okay. It can become electrical energy. All right, all right, all right. Who else has got something? Wave at me. That's all y'all got? Oh, there's so much more. So much more. Come on. Still doing packs.
Heat energy is useful for purposes of heating pads or.
Yeah, I'm gonna keep that with what you said earlier. Source that is useful and helpful, because I think that anytime we can just heat things up, it's just generally useful and helpful. Come on.
Heat energy can be energy produced by the sun.
Produced by the sun. I like it.
This next weekend is that.
What else? Leah.
It's also heat,
It's what?
but this night,
Yes?
I had a connection problem in the computer.
Okay. So anybody got any more facts about heat? Jeremiah.
Some heat can give us light.
Some heat can give us light. Leah.
And light, because when you touch the sun, you will burn yourself.
Oh, you would go to smithereens. Yes. All right, let's talk about examples of heat. What are some examples of heat? And this list can go on for days. Examples of heat. Jeremiah.
A light bulb.
A light bulb. Iridescent light bulbs. Anli. Natalie.
Stove.
A stove. Layla.
A fire.
Fire. Leah.
The sun.
Bipaswi.
An apple.
Kamani.
A lamp.
Scarlet.
Stove. I think I was say that.
No, we had that.
Hot pan.
Hot pan. Luke.
Metal.
Hot metal. Anli. And there we go again. Leah.
The sun.
We got that. Tyler.
A coffee maker.
Oh, yeah. Natalie Lopez.
The inside of your computer.
Wow, that generates heat, doesn't it? All right, so again, this list can go on and on and on and on, right? So we're not going to write all of them down because I'm pretty sure that we could fill up all the walls in this room of my class with ways that we can give examples of heat energy. I'm going to go ahead and move on to light energy. I'm going to read it to us. Don't know that we'll have too much time. I do recommend that we are not going to have time to go through all of these. So what you're going to want to do is make sure that you go over the rest of these tonight if you have time, if you want to. It is not a requirement, but you do have a test tomorrow, okay? You do have a test tomorrow. So you want to be able to be successful on it, so you want to go over all of this. So I'm going to go ahead and read this light energy. Light energy is all around us. It travels in waves. The waves travel outward from its source. Light always travels in a straight line. Now remember, sound is in waves, in curvy waves. Light is in straight lines. Light helps us see. Without it, many things would be impossible. Some examples of light energy are a light bulb, a candle, a fire, the sun, and a flashlight. Light from the sun takes about 8 minutes to travel to the earth. Wow. Light can travel through empty space where there is no air. When light travels through space, it travels at a speed of 300,000 kilometers per second. Light can also travel through matter like glass, water, or air. When it travels through matter, it moves slower. So I think we have a couple of minutes where we can fill in a couple of these pieces. So let's see what we can fill in. Who wants to fill in a piece of this? Chloe, were you raising your hand because you wanted to fill in a piece of light?
I was gonna ask something about that little thing that you did.
Okay, well, let's answer these questions first. Tyler.
You can use light to
What did we just see? What did we just read?
you can use light to see.
Yep. Kamani, did you have your hand raised a minute ago? Yeah, you do. I see you. Okay, Kamani.
You can use lights to decorate on holidays.
But we didn't read that. Although you are correct, we didn't really read that. We're looking for characteristics of light energy. Characteristics of light energy. Scarlett.
Light energy travels in waves.
Travels in waves. Straight lines, right? Straight line waves. Leah.
Without light, nothing would be impossible.
Without light.
Without light, everything would be impossible.
Okay, so without light, things would be impossible. I don't know. Did we read that? I don't know if we read that. Did we read that?
No.
I don't think we read that. I don't think that's something that would, I don't think it's going to make it impossible. I think it's going to make things difficult, but maybe not impossible. All right, I am going to stop there because of time. So, again, I know we didn't get through all of this. It's just kind of sometimes the way it goes. Here's what I'm going to tell you. Get through what you can. Go read those slides. Go through those videos so that you are fully equipped for your test tomorrow. All right? All right. I will see you guys a little bit later. Bye. What?
My camera slides all the percent pages. Because if I go into it, all I see is just heat energy, heat energy, heat energy.
Oh, really? I'd have to go look at it. Then go to the Google Slides. That stinks. I'm sorry.